Well, hello, welcome to class. I have a little bit of a weird angle here because I'm writing on my tablet, and it makes it a little easier for me to write with my wrist this way. If you're wondering why the angle is like this for the video I'm recording, I'm just screen recording my tablet. But here we are at the beginning of our Algebra 1 course, so welcome. We can have kind of a little preview here of chapters 1 and 2, for example. This is the entire course. But here we have, for example, we begin with expressions, equations, and functions. And then chapter 2, we'll move on to properties of real numbers. Now, where are we going to begin today? We're going to be taking a look at some prerequisite skills for the course, along with the very first section here in chapter 1, evaluating expressions. So let's go over to 1.1 and first take a look at our prerequisites. So a few ideas that we're covering here from our previous course in middle school math is most likely where we were at here prior to Algebra 1. Or maybe you're taking Algebra 1 in 8th grade and you're sort of in an advanced track. But let's just take a look really fast at a few ideas. So if I write the fraction, for example, 2/3, I know that 2 is my numerator. On the top, it tells me how many equal parts that I have. And then 3 on the bottom, our denominator tells us how many equal parts there are in total. All right, two fractions that represent the same number are called what kind of fractions? Equivalent fractions. Now they do need to have the same multiple being multiplied each time. For example, I could have 1/2 equals 2/4. So I went up times 2 here, I went up times 2 here. Because they both are being multiplied by 2, the value is still the same. These are equivalent fractions. Now the word percent means divided by what number? So it means literally per 100. And whenever we see a percent, we can think divided by 100. We ask what number does percent connect to? 100. So for example, 23%, we can write that as 23 over 100. Now let's take a look at adding fractions with different denominators. For example, we have 2/3 plus 3/5. So we need to have the same denominator. We're trying to get a common denominator so that we can simply add our numerator straight across. For example, we cannot add thirds and fifths together. So we're going to rename them with a common denominator. So let's use 15ths as we're looking for our number that they both can go into. We're looking at 15ths. All right, wonderful. When I list my multiples of 5, I see that 3 and 5 share common with 15 in our multiples. So then I ask myself, 3 times what is 15? In this case, it's 5. And now I can multiply 5 times 2. And the same thing here, I can ask myself how many times does 5 multiply to get to 15? That's 5 times 3. And then I multiply 3 times 3 is 9. And now I have a common denominator, so I can add my numerator straight across. 10 plus 9 is 19. 19/15. Now I can divide this out to get to my mixed number. 15 goes into 19 once, subtract 15 with 4 left over, 1 and 4/15. Both are correct. 1 and 4/15 or 19/15. And the same applies for subtracting. So let's say we are subtracting 5/6 minus 3/4. 5/6 minus 3/4. We're looking for that multiple here that both of our factors will go into. So we start at the multiples of 6. 6, 12. Oh, there's 12. Okay. 12. Both 6 and 4 can go into. So our least common denominator here will be 12. Now we have a common denominator based off those multiples. We start at the bigger number there, 6. So 6 times 2 is 12. 2 times 5 is 10. 4 times 3 is 12. 3 times 3 is 9. Now I can subtract 10 minus 9 to get to 1/12. Denominators stay the same. What about multiplying? Here we can multiply 3/5 times 2/3. These are fairly straightforward. We're just going to multiply straight across our numerators and our denominators. 3 times 2 is 6, and 5 times 3 is 15. 6/15. Now, how do we reduce this? How do we simplify this? We're looking for a common factor. The greatest common factor that can divide both of these down. So when we're listing out our factors, for example, we start with 1 and the number itself. If it's even, 2 will go into it, for example. And then for 15, 1 and 15, 2 will not go into it, but 3 will. It's 3 times 5. Here are the factors. Now we're looking for the greatest common factor. So let's take a look. 6 and 15, 3 and 5, 3 and 3. Oh, there we go. That is the highest common factor, so let's divide both by 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. So this reduces down to 2/5. Now let's divide a fraction real fast. Let's try 1/2 divided by 5/8. Here we are going to multiply by the reciprocal. So keep, change, flip is what we learn in school. We're going to keep 1/2. We're going to change division to multiplication, and we're going to flip 5/8 to 8/5. That's the reciprocal, is when you flip it. And now we're back to a simple multiplication with fractions problem where we multiply out the numerators and the denominators. Here we'll have 8, 1 times 8, and 2 times 5 is 10. And again, we want to divide by our greatest common factor. All a factor is a number that's multiplied by another number. A number being multiplied by another number, those are factors. So for example, we know these are both even, so we can start there. Divided by 2, we already know that that's a common factor. And this will bring us down to 4/5. Now let's write percent as a decimal. This is fairly straightforward. We're just considering place value and moving our decimal place over. Now we are dividing by 100 when we're considering percent as a concept. So for example, 4%. We want to start at the whole number, and we're dividing by 100. So we want to hop over 2 places to the left, 1, 2, to get to 0.04. What about 23%? Again, we start where the whole number will be. For example, 23.0, and we hop over 2 to the left, 1, 2, because we're dividing. So 23% will become 0.23. Pretty straightforward, pretty simple. Just hop over to the left twice. What about if we have a decimal with 0.5 at the end, like 1.5%? Okay, here we have a percentage that's in decimal form, but we still practice the same method, 1, 2, but it's going to be a smaller number here, 0.015, a smaller decimal. How about 2.5%? 2.5% then becomes 0.025. All right, what if I have a question that says find the perimeter and area? So I have perimeter, find the perimeter and the area of a rectangle. It's going to be 11 inches. And we know our width is 4.5 inches. Now we need the perimeter and the area. All right, so we have formulas that we can use for perimeter and area. For example, perimeter is 2L plus 2W. And area is length times width. L times W. So we have 2 times the length, 2 times the width. And then for our area, we have length times width. Now we'll be giving that in inches squared when we multiply. So let's compute our perimeter. This will be 2 times 11 plus 2 times 4.5. Now this will bring us down to 22 plus 9. (22 plus 9 equals 31. Excellent. So we have our perimeter, 31 inches. What about our area? Area will be 11 times 4.5. Let's convert 4.5 to 4.5. 4.5 inches is 4.5. So we have 11 times 4.5. This is 49.5 inches. Squared for our area. Also can write that 49.5. 49.5 inches squared. Or I can write IN squared. All right, that is our review of our foundational skills. Now we're ready to jump straight into the first section of chapter 1. Foundation over, let's move straight into algebra.